Hello and welcome to Commercial Building Energy Auditing Procedures. This training is going to be in two modules, Module 1 and Module 2. But in addition, I'm going to break them up into parts to keep the videos at a reasonable length. And so this is Module 1, Part A. The learning outcomes for Module 1 are to be able to define the levels of effort for commercial building energy audits, identify what data collection is needed and the information required for an audit, how to calculate the energy use intensity and create an energy benchmark, and then determine some end-use allocations. There will be a follow-up module, module number 2, after this one, and the learning outcomes for that one will be identifying energy efficiency measures, estimating the energy and cost savings, how to do a simple payback calculation, and what goes into developing an energy audit report. A recommended handbook for commercial building energy audits is actually written by ASHRAE, American Society of Refrigeration and Air Conditioning Engineers. And what I'm showing you here is where you would purchase this handbook. It's $146, but if you're an ASHRAE member, it's $110. You do not need to purchase this book for these training modules, but you may find them helpful. They're available in PDF or in print form. I keep a copy here at my office, and I found it incredibly useful and easy to read. So this course, this training series, is commercial building energy audits. First of all, what do we mean when we say commercial building? Well, according to ASHRAE, a commercial building is anything that's not a residential building. What I'm showing you here is the front cover to the ASHRAE Standard 90.1, the latest, which has been released in 2022, and it says the energy standard for sites and buildings except low-rise residential buildings. Now that's what ASHRAE defines as commercial, anything that's not a residential building. And if you did if you worked in the residential sector and you were looking for the ASHRAE energy standard for residential buildings, you would find a standard called 90.2. So 90.1 is for everything that's not residential. So technically, you could say that anything that's not been described or categorized as a residential structure would be a commercial building. Okay, that makes sense. But what about industrial and manufacturing facilities? Well, those facilities are generally shells, big buildings that are structured such that they have a very high internal load. They have some kind of process going on that uses a lot of energy for that process, for manufacturing or for some industrial. And so those usually are put into a category of their own of industrial or manufacturing. And so most people think of the commercial sector as those that encompass schools, hospitals, generally office buildings, theaters, restaurants, those facilities used for a commercial, quote unquote, purpose. So that is where our focus will be, is on the commercial sector, schools, offices, churches, theaters, etc. I think of industrial and manufacturing facilities as those structures that have a very high internal load, meaning that that process inside is using a lot of energy specific to that function. And the commercial buildings will be more, their energy use is more around HVAC, lighting, people, and the equipment that they use, like computers and things like that. ASHRAE, in their handbook, and other entities have defined energy audits as processes in which engineering service providers identify and recommend efficiency opportunities to their clients. The objective of the energy audit is to identify and develop these measures that will reduce the energy use and or cost of operating the facility or building, and possibly improve the indoor environmental quality experienced by the occupants. ASHRAE identifies basically 3 levels of effort for energy audits. Level 1, the most preliminary level, is what they call the walkthrough survey. Level 2 is more of an energy survey, and level 3, we go into a much detailed analysis. And then there's also something called a targeted audit that is detailed but limited in scope. We'll look at each one of these in a little more detail. Prior to doing any of the energy audits where you go on site and conduct a survey, there's one thing that is mandatory to do, and one of the most important aspects of an energy audit is the preliminary energy use. This is where we take historic utility data and we look at the energy use for each of the fuels that are used at the facility. For instance, if electricity, natural gas, maybe it's propane, there could be even biofuels, whatever. And then we look also at what is the peak demand. I'll discuss more of the differences between the energy use and demand in coming up lectures. And then we do a calculation. We do which is called the energy cost index, and then we also do an energy utilization index. And I tell my students these are probably the 2 most important calculations to do, and you'll see why when we talk about benchmarking. Historical building utility data is usually obtained from the owner or the operator of the building before you go on site. And monthly energy use, power demand, and the cost for at least 12 months of utility use should be collected. If you can get 3 years of data, that is even better, but you need at least 12 consecutive months of utility data. What I'm showing you here is the actual utility bills for a community college building in Portland, Oregon. They have, on this site, they have natural gas and electricity. Gathering information directly from utility bills is very complicated, and all utilities bill their customers differently. And so that's a little bit beyond the scope of this training module. But what I want to show you is in electricity, there's a couple things that are important. First of all, the total amount paid for that month, and the kilowatt hours that was billed for that month, and something called the demand, which is in kW for that month. That's the 3 key pieces of information that you want to find. The rest of it are what we'll call other charges, and those have to do with surcharges, taxes, and so on, which are unique to each location and each utility. And here I'm showing you the natural gas bill for this facility for a month. And again, they have the amount due for that month. And natural gas is billed in something called therms, which I'll discuss in a moment. But they'll give you the total therms that were billed for that month. And then again, they have a lot of other additional charges. They'll have service fees and taxes and so on, which again are unique to each location. So the monthly energy use, in this example, electrical and natural gas, needs to be collected and then put into a useful format using typically an Excel spreadsheet, as I've shown here. There's another example, figure 4, on page 27 in the ASHRAE Procedures Handbook that also shows another way of organizing your utility data. So what I've shown here is the utility data for that community college building in Portland for a whole year. And you'll see I have kilowatt hours, that's the electrical use for each month, and then it's totaled up. And then the charge per kilowatt hour for each month, then totaled. And then this is called the demand. That's the peak electrical load in each month. Utilities like to charge for demand, and sometimes it can be fairly significant. As you can see here, they paid $14,556 in demand charges for the year. and $45,000 in electrical charge. And then these are those supplemental fees which I pointed out before. For natural gas, they paid in therms, and this is for the same year, the monthly therms, the cost for each month, and then those other supplemental charges are tabulated here. Once you have your utility data compiled into a useful form, you're going to have to do some math. We need to convert the energy use for electricity and for natural gas and for other utilities too, if they exist, into a common unit. And in our industry, in this industry, that common unit is something called the kBTU. And shown here are the conversion factors that are generally used in the industry. A therm in natural gas is the same as 100,000 BTUs. A kilowatt hour is 3,412 BTUs. I've seen this last digit range from 0 to 4. I use 3412. If you Google it, you might find something slightly different, but this will work. And 1 kBTU is the same as 1,000 BTUs. Other fuels will have different conversion factors, but again, that's beyond the scope of our work for this tutorial. So let's do an example. For February of that building that I showed you previously, there was 53,888 kilowatt hours of electrical use in the month of February. So we want to convert that to kBTUs, and using our conversion factors and doing the math, we get about 183,839 kBTUs of electrical use for that month, which happened to be February. Now we do a similar analysis conversion for natural gas, and for that month of February, we had 4534 therms that were billed to our building. And so to convert that to kBTU, we get 453,400 kBTU of natural gas. So now we have our electrical and our natural gas into the same common unit. And that's important. So why do we do this? Well, we have to analyze the utility data under a common unit of measure, which in the industry is the kBTU. And once we have that, then we can do a spreadsheet as I've shown here, where I take the natural gas therms, convert it to kBTU, insert the cost, electrical data in kilowatt hours, convert that to kBTU and the monthly cost, and then I can add them up. I can add up and get the total energy and total cost per month for that building, because then I can do a comparison of the energy cost per square foot per year and the energy use in kBTU per square foot per year. This is our ECI, Energy Cost Index, and this is our EUI, Energy Utilization Index. In the preceding slides, I showed you how, using utility data for a facility, how to come up with the ECI, which is the Energy Cost Index, and the EUI, which is the Energy Utilization Index. The Energy Cost Index is the cost paid per square foot per year. So you simply take the annual cost of energy divided by the square foot, and that will give you the cost per square foot for that year. And the EUI is similar, but since utilities are different fuels and billed at different utility rates, a little bit more complicated, we had to put our energy use into a common unit of measure, which we use as the kBTU, and then combine that, all of those utilities, and we can get the energy use per square foot per year. So why do we care about these? Why are these important? Well, it can be used to see the performance of a facility over a period of time. If a facility manager is tracking their energy use through a number of years, they can see Is the EUI increasing or decreasing over a period of time? And how is the cost changing per year? It can also be used to compare a facility to other similar facilities in a general geographic location to see how does this building perform relative to other similar buildings. This leads us to the topic of benchmarking. For those of you that are following along in the reference book procedures from ASHRAE, benchmarking is discussed on page 32 to 34. Basically, what we are doing is we're creating an energy benchmark for the building. Benchmarks are established based on historical utility data and building characteristics, and they allow the building to be compared with similar buildings or for that building over a number of years. Now at this point, you will have an assignment to do, assignment 1, and a quiz based off of the information provided in module 1A. So here is assignment number 1. In assignment number 1, titled Utility Data Analysis and Calculating the ECI and EUI. So you're going to take some historical building utility data, which I will give to you, and you will calculate the energy cost index and the energy utilization for a community college building in Portland, Oregon. So I give you the data, and one thing to point out that's very important is the floor area is 49,111 square feet. So here is the Excel spreadsheet that you'll be working with, and this is, I've given you the electrical data and the natural gas data. And what you'll be working on for the ECI is the kilowatt hours and the charge for the kilowatt hours. And also for natural gas, you'll be working with the therms and the cost per therms. Now remember in the discussion, kW is the peak load, and we're not going to worry about that for the ECI and EUI calculation. And also we will not include other fees or other charges into our calculation. So this is the spreadsheet, and this is the utility data tab. So if you click on the energy use data, this is what you will be developing. So I have the template developed for you, but what you need to do is you need to import the therms data and the kilowatt hour data, the natural gas cost, and the kilowatt hour cost. And then you need to convert from the natural gas therms to kBTU and convert the electrical kilowatt hours to kBTU. And then in these two cells, you will, well, these two columns, you will add up the total kBTU and total cost. And you will use this data to then come up with the energy cost per square foot and the energy use in kBTU per square foot. This is your ECI and this is your EUI. What I have here is what you will submit. I want you to, well, it's up to your instructor, but what I'm going to recommend is that you write your assignment work in a memorandum format so that it looks professional, and also so that everybody submits the same thing. And you'll fill out what I have here in red is what you will provide. And then also I recommend that you provide also your Excel spreadsheet so that the calculations inside the spreadsheet can be seen. So this concludes Module 1 Part A, end of this video. Next video will be Module 1 Part B, and that's where we'll go into benchmarking.